reach that I would like to explore further. And those coordinates are given back to the surface vehicle, which is the boat, and the underwater vehicle will go closer and take more snapshots. So this was a collaboration that we did at McGill while I was a grad student there, and we worked with the marine biologists to kind of see that if robots can do this task autonomously. Of course, we are not there yet because, as you can see in some of these scenes, we are actually putting our fingers crossed and praying to our gods that everything goes well and we are floating in the water along with the robots. So it's definitely a very challenging problem, and it's at a very large scale as well. So the idea was to be able to understand some of these challenges that comes from cross-domain robots talking to each other and at the same time making use of the learning and vision-based techniques that come along with it. Right, so some challenges that I wanted to highlight today and give you a bit of insights about what we are doing here is, first of all, what these robots need to do when they are in different domains is to dynamically figure out where should the meeting points be between the robots. Because if they have fixed meeting points, in a real world scenario, things can change, there can be noise and other factors that will not allow them to meet at the same locations. Secondly, they are drones that are actually able to capture the bad drone. So the bad drone is further out on the edge of the lab, and then these drones are going to come into formation which was never taught to them in advance, but they actually learned on the go based on the information propagation in the network. So what we were successfully able to do here is to give them heterogeneous roles. Even though they are in the same domain of aerial domain, they had different roles. So some of these drones were scouting for new targets, whereas some of the drones were actually pursuing for the target which is readily known to them. And if you'd see over time, they would do the formation and circle in the bad guys. So in interest of time, I will just quickly play a little of this video so that you can see. But they form together and come into a consensus to capture the guys. Right, so which kind of?
Swarming techniques.
Oh yeah, so we did the AAA swarming techniques, which is avoidance and attraction and affordance. So these three together actually are traditional ways of doing it. So instead we learned these swarming techniques over multiple simulations. So there was no single swarming technique, it was all the learned behaviors that the robots had in the simulation process.
So all the robots were having different tasks?
Yes, they were trained to do different tasks during the simulation process, yes. So it's under the concept of centralized training, where all the robots kind of share the knowledge when they are training, but when they are executing, they are decentralized. So based on whatever they had rehearsed in the simulators, when they are actually deployed, they don't have to communicate and they can figure out what the other agents are thinking or doing. Yeah. Thanks. Are in the environment, and at the same time you're working with marine biologists, so they kind of know what locations that they are sending us to, and they've been diving the same place like over 10 years now, so they know those locations very well. So we kind of know our limitations as to where to go and where not to go. Yeah, at least in this case. Yeah. All right.
Regarding the first video, do you have manual control in case there are technical issues or in case of emergencies?
Yes, absolutely. And we were counting on it because this was the first time we deployed it and we didn't know how would it go. So absolutely, behind each of these vehicles there is a human somewhere like praying, crossing fingers and holding a joystick in hand saying that okay, may not or may be needing it. Yeah.